Good afternoon, and welcome to your science review with Mr. Blades. Let's get started. You can see I've already written down our knowns and unknowns. We have our frequency, our mass, our radius, our table of unknowns, and our relevant equations. We have circumference, linear speed, angular speed, acceleration, and force. Now, our circumference is calculated 2 pi times r. We know our radius, which is 2 meters, so 2 pi times 2 meters gives us 12.57 meters. Next, our linear velocity is equal to our circumference multiplied by our frequency, or 12.57 meters per revolution multiplied by 0.2 revolutions per second. We can see that the revolutions cancel out in our math, and we are left with 2.514 meters per second. Let's box those up and go ahead and write those in our table of unknowns. Next, you can see that I've written two different equations that will give us our angular speed. Now, you use either one of these depending on how much information you have. Whichever one works gives you the same answer, and let's prove that. 2 pi times frequency gives us our angular speed, so 2 pi times 0.2 is equal to 1.26 radians per second. Likewise, we can also take our linear velocity, 2.514, divide it by our radius, 2, and see that it also gives us 1.26 radians per second. I'd like to emphasize you just use whichever equation you have enough information to solve. Either one works, gives you the same exact answer. So let's write that into our table of unknowns, 1.26 radians per second. Next, this one will feel new. Acceleration is equal to our linear velocity squared divided by our radius. So we'll just take those two, 2.514 meters per second, whole thing squared, divided by our radius of 2 meters. One of those meters cancels out, and we're left with 3.16 meters per second squared. And lastly, one of our most used equations, F equals ma. Force equals mass times acceleration. Now, it feels new, but we can use the acceleration we just calculated the same way we would use any other acceleration. So we have our mass of 0.5 kilograms, our acceleration of 3.16 meters per second squared, and we punch that out and get it 1.58 newtons. Now, the importance of that number is that's how hard somebody would have to pull on the string in this system to keep everything together the way it is. Now, I hope this was helpful, and I'll see you in class.